Hello, I am Abhilash Sharma and I am going to present a paper on secure data collection, storage and access in cloud assisted IoT by Wang, Zhu and Yang. The Internet of Things IoT, as we all know, is the following type of correspondence. Is the following time of correspondence. Utilizing the IoT, actual items can be engaged to make, get and trade information in a consistent way. Different IoT applications zero in on mechanizing various errands and are attempting to enable the lifeless actual items to act without any human mediation. The existing and upcoming IoT applications are highly promising to increase the level of comfort, efficiency, and automation for the users. This also brings up and this includes this requires high security protection and validation of data. In such manner, it is basic to roll out the necessary improvements in the design of the IoT applications to make IoT conditions more secure. The convenience that cloud brings to IoT comes at a cost of potentially new security risks which have never been considered in traditional IoT systems. In both theory and practice, a cloud is widely recognized as an honest but curious party. This means that a cloud will handle user dedicated tasks but hardly guarantee confidentiality of user data. A trust-based system is applied as a solution to the security risk. However, such a system cannot provide provable security for dynamic operations like insertion and or deletion, especially when merging with the cloud. In a traditional cloud-assisted IoT system, the users delegate the data collection task to the cloud, store it there and access from cloud only. This could lead to potential attackers when bridging IoT data to cloud. The work presented by Wang, Zhu, Yang in their paper finds a solution to the problem of securing the data while collecting, storing and giving access to it. The proxy re-encryption scheme called CIBPRE, which we call as conditional identity based broadcast proxy re-encryption, it was considered in the implementation. This method provides security when re-encrypting data in the data collection step and extending keys to the user by the key generation center. This helps attackers within IoT devices and from outside. The possible attackers are eavesdroppers. An eavesdropper can obtain all the transfer data such as the data transferred between IoT edge object and the cloud and the data between the cloud and the users. IoT edge objects, it could be existing object being controlled by attacker or introducing new edge objects. Cloud, which we always called as honest, which does not look at the authenticity of the user and provides all the information. And users that access IoT data from cloud, they can be different users having different rights on the cloud. To handle eavesdroppers, all communication is to be done through secure channels. To handle adversarial IoT objects, all of them should have their own keys to encrypt data. All the data to be stored as ciphertext in the cloud as against the earlier implementation which had only stored as plain text. Encryption based access control to data stored in cloud. Now how we implement this confidentiality in data collection? We'll see this first. Users send their data collection request and identities to the cloud. Suppose the users in the identity set are S and they want to collect data F from the IoT edge object. The cloud sends the set of S, which is the identity set, and the data collection request to the IoT edge object. The IoT edge object verifies the user's identity in the set and removes the invalid entities, which means those objects which don't have authorized access. The IoT edge object chooses a data sharing condition, encrypts the data using an algorithm, and sends the ciphertext to the cloud. The cloud stores the ciphertext and the set of the users that have access to that those who are authorized to see that, and forwards this ciphertext and the set of users all the users in the set S, which is the identity set, they decrypt the data using their own algorithm. So it is encryption of data on the edge object, sending it to cloud sending it to the identity set, and those individual objects, they decrypt it using their algorithm. They have their own keys. The keys are not shared between objects. Now, the data is also stored in cloud. We just saw this will be ciphered text in the cloud, which is encrypted and not shared with the devices directly. So there is an edge object between cloud and the devices. Then confidentiality in data access. How this confidentiality while sharing the data between objects is maintained. The user A, suppose, sends his identity and the data sharing request to the cloud. Suppose that all users in the identity set S want to share the same data of user A. The cloud sends the data sharing request and the set S to the user A. The user A verifies the validity of the identities in the set S, which is the identity set, and removes the invalid identities, which means those who don't have access, authorized access, they are removed from that list. The same condition that was used to generate the initial ciphertext is applied again and generates and resends a re-encryption key. The same algorithm is used and the same key is sent for re-encryption to the cloud. The cloud re-encrypts the initial ciphertext to generate a re-encrypted ciphertext and sends it to the user of the identity set. All the users in that set, they get the data, they decrypt the re-encrypted CIBPRE ciphertext using their own algorithm and their own keys. Again, the keys are not shared among all the objects. About this paper, so only intra IoT devices can use the system because of the kind of encryption that is followed in the process. The encryption happens on the IoT device, which could limit the amount of data to be processed at a given point of time because the data keeps on coming regularly. The CIBPRE based encryption, this allows to encrypt only one type of data at a time. For example, heart rate. This becomes infeasible if multiple type of data is to be processed at a given time. The implementation does not talk about the scalability of the cloud. So how can we improve that? The logic of encryption can be moved to the cloud and make it smarter. This will lessen the load on the IoT device and allow it to capture more data. The CIBPRE based encryption allows to encrypt only one type of data instead of having some fine grained conditional PRE scheme which supports multiple type of data. And blockchain technology can be thought of as part of the system which sits behind IoT edge object and the cloud. This will also help in prevention of adversarial attacks. Thank you for watching this. Have a nice day.